Hello students, welcome to the third chapter, that is squares and square roots. So square, what is square? The product of any number by itself. Okay, when a number, suppose there is any number a, when it is multiplied by itself, that is a. When a number is multiplied by itself, then the product which we get, okay, the product which we'll get after multiplying it, that would be a square. So this product is called square. So product of any number by itself is called square. What is a perfect square? A number is called a perfect square only if it is a square of any number. Okay. What is this? This is a process that multiplying one number by itself, multiplying any number by itself is square. But what is perfect square number? These products, okay, the answer which we get after multiplication, they are perfect square numbers. Okay, so a number is a perfect square only if it is a square of any number. So for example, I have written a few numbers here which are 1. 1 is square of what? 1 ones are 1. Again 4, it is 2 twos are 4. 9, 3 threes are 9, and 16, 4 fours are 16. So these a few numbers which I have written here, they are the product of some numbers by itself. Okay, so they are these numbers are the product. So these numbers are perfect square numbers. Okay, not all numbers are perfect square. For example, suppose if I write 5, so this is not a perfect square number. Okay, because if we multiply any number by itself, then we will not get 5. Next, there are a few methods to check if a number is a perfect square or not. Okay, there is a little trick. For example, that is, if a unit digit of any number is 1, 5, 1, 4, 5, 6, 9, then it must be a perfect square number. Okay, if there is a very large number, suppose I'm giving you 169. Okay, there is a 3-digit number. This is a 3-digit number. So if there is any number, and if the unit digit, unit digit, the last, the number with the digit with which the number last ends. Okay, so the last digit, if the last digit of any number is 1, 4, 5, 6, 9, then there is a possibility that that number could be a perfect square number. Okay, it's not necessary that if a number is always ending with these digits it would be a perfect square, but if a number is ending with any of these digits, you can at least try and find out if it is a perfect square or not. Suppose there is a number which is ending with what? 103. So it is ending with what? 3. Okay, so it is not ending with any of the digits which is given over here. So I know that this wouldn't be a perfect square number. So I don't need to find out or do any other thing to tell that this is not a perfect square number. But here is a number 169, and I'm giving you one more number 109 or 104, suppose. Okay, so both the numbers are ending with, one is ending with 9, one is ending with 4, and here the digits which were given to us, 4 and 9, both are present. So there may be a possibility that one or either both of them are a perfect square number, or any one of them are perfect square number, or maybe none of them are a perfect square number. But since they are ending with one of these digits, so I will try to find out that if it is a perfect square number or not. So to find out if the number is given or is a perfect square or not, you can do 2 things. To save your time, you should know the perfect squares till from 1 to 20. Okay, 1 to 20, your perfect squares you should know. Perfect squares are from 1 to 20, and also that would save you some time. Okay, if you would know that the squares, then you can easily tell that 169 is a perfect square of number 13. Okay, and 104 is not a perfect square because ये किसी भी नंबर से मल्टीप्लाई करके 104 नहीं आता है सिमिलर नंबर से. Okay, or the other number other method which you can apply if you don't know the perfect square, the other method which you can apply is prime factorization method. Okay, since 13 is a prime number, so this number will only be divided by 13. So 13s are 169 and 13 ones are 13. Okay, so if any number is a perfect square number, it will form a pair of similar numbers. Okay, now if I do the prime factorization of 104, so what will I get? 2 5s are 10, 2 2s are 4, then 2 2s are 4, 6 are, then 2 1s are 3s are, and then 13 1s are. Now see what are the numbers which I'm getting. I've got 2 2 2 and 13. So to find if the number is a perfect square or not, what we'll do, we'll make pairs of similar numbers. Okay, so 3 2s are there, so using the first 2 2s, I'll make a pair. Then there is another 2, but there is no other 2 to make a pair with. Okay, so there is only 3 2s, and then there is single 13. So I can't pair these two up. They are not similar numbers first of all, and also there are no other identical 2 or 13 to pair it up. So if you are getting any number which you can't form the pair of, then that given number wouldn't be a perfect square. For number to be a perfect square, it has to form pairs. All the numbers have to form pairs. See here, only 13 is there. Okay, only one digit there, but there are 2 13s, so I formed a pair. So none of the number or no other number is there without pair. Okay, so this is a perfect square number. I have one more number for you, 125. So first we'll do it with 5. 5 2s are 10, 5 5s are 25, then 5 5s are 25, then 5 1s are. So what have we got? 5 5 5, 3 5s we have got. Okay, so we can make a pair from first to 5, but then again there is one more 5 for which we can't pair it up with anything. Okay, we don't have one more 5, so this 125 is not a perfect square number. Okay, if you have to find out one more, I can give you one more number. See, this number also, first of all you just see that what is the last digit. 4. Again I said that if the number is ending with 4, it may be, not necessary. Okay, 104 was also ending with 4, so it could have been, but it is not a perfect square. So 144 could also be. So let's try. It is a prime number, it is a even number, so we'll start with 2 2 7s are 2s are, then 2 3s are 6s are, then 2 1s are 8s are, then 2 9s are, then 3 3s are 3 1s are. Okay, so now let's see if we can pair it up. So there is 2 2. Okay, then again there are 2 more 2s, then there are 2 3s. See, all the numbers given here have been paired up. Okay, paired up. So if you want to know that of which number this is a perfect square, so what you will do, you will just take one number from each pair. So 1 2 from here, 1 2 from here, and 1 3 from here. So what we'll get? 2 2s are 4, 4 3s are 12. So that means if we multiply 12 by 12, we will get 144, or 144 is a square of 12. Okay, with these concepts in mind, we'll begin with the explanation of the first exercise, that is your exercise 13.1. Okay, the first question is, what will be the unit digit in the square of the following numbers? You just have to know the unit digit. You don't have to find the squares, okay, or perfect squares, anything. You just have to tell that whatever number is given, what would be at the last digit of the square of that number. So if 16 is the number, then how will we find the square? By multiplying 16 by 16. So 16 into 16. So if you do the multiplication, 16 into 16, what you will get? 6 is the 36 and 3 carry 8, 6 1 is 6, 9. Okay, so you have to do what? Simple multiplication, and then you just do the addition. The last unit digit is ones digit. You have to find what would be the last digit. So here the last digit is 6, so unit digit is 6. Similarly, there is one more part I've done, 9284. So you have to find what would be the unit digit if we multiply this number by itself. So here in both the parts which I've done, I have shown you complete multiplication, okay, but in test or in your exam, it is not necessary to show complete multiplication. Okay, what you can just use this one trick, just multiply the last digit by itself. The last digit of the question is 4. Just multiply 4 by 4 and see what is coming. You are getting 16. Okay, 6 is the last digit. See here also 4 4s are 16, 6 is the last digit, and you always know that the last digit in the first line of multiplication is copied as it is. उसके नीचे बाद में हम लोग कुछ भी नहीं लिखते हैं, we just put cross. ठीक है, तो जो भी लास्ट डिजिट होता है फर्स्ट लाइन ऑफ मल्टीप्लिकेशन में, वो वैसे के वैसे ही उतारते हैं हम लोग. So instead of doing the complete multiplication, you can just multiply the last digit of the given number in the question by itself and see what is coming. Okay, whatever the answer is, just copy, just take the last digit. Suppose I'm giving you one more number, 105. You have to tell what would be the unit digit of this number. So again, 105. What is the last digit? 5. So just multiply 5 by 5. That would be how much? 25. So the last digit of 105, square of 105 would be 5. Again, taking one more example, 1981. Okay, 981. Okay, so what is the last digit? 1. So if I want to know that what would be the last digit in the square of 981, what will I do? I'll just multiply 1 by 1. That would be 1. Okay, so the last digit in the square of 961 would be 1. I hope this is clear. Next question is, which of the following numbers would have digit 6 at its unit place? Okay, they want to ask that which of the given questions will have 6 in the unit digit. Okay, so as you already have done how to find the unit digit of the perfect square, so we'll follow the same sequence. You can also do the proper multiplication. Okay, there is a 4-digit number or 3-digit number, you can always do proper multiplication and find out the last digit. Or if you don't want to do that, okay, you can just multiply the last digit and find out the unit digit in the product. Okay, so the question here is 4368. So last digit in this number is 8. So I have taken 8 and multiplied it by 8 again. Okay, 8 8 is 64. So the last digit of the square of 4368 would be what? 4, which is not 6. They are asking which number would have 6 in the last digit. It has 4. So the answer statement would be 4368 square will not have unit digit as 6. Okay, next part is 324 square. So the last digit here is 4. So multiply 4 into 4. 4 4 is 16. Last digit in this product is what? 6. So this has 364 square will have unit digit as 6. Easy question. Moving on to the next question, that is, how many square numbers are there between 1 to 100? You just have to find the square numbers. Okay, so for that you don't have to do anything. You just have to write the squares from 1 till the squares cross 100 or reach 100. Okay, so 1 1s are 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36, 7 7s are 49, 8 8s are 64, 9 9s are 9 9s are 81, 10 10s are 100. Okay, so I have got 1 also and 100 also. They are asking how many square numbers are there. So how many square numbers are there? You have to find between. So we will not count 1 and 100. We have to count in between. So these are the square numbers which are in between 1 and 100. So there are 8 square numbers between 1 to 100. Okay. Next is, find the smallest 4-digit number which is a perfect square. You have to find the smallest 4-digit number. Okay, so let's see what is the smallest 4-digit number. Smallest 4-digit number is what? 1000. That is 1000. Okay, since the number is ending with what? 0. Remember that statement. Okay, number here is ending with 0, and the digits here this number is not ending with what? 1 4 6 9. Yes, so this is not a perfect square number. It is not ending with any of these numbers, or 5 also. Okay, it is not ending with any of these number. So only after seeing the number 1000, that is 1000, I can tell that this is not a perfect square number, because it is, the unit digit is not even 1 or 4 or 5 or 6 or 9. Okay, so even just so that I already know, how would you know if you don't remember this? So what you'll do, you will just do the prime factors. Okay, so let's do the prime factors. 2 5s are 10, 0 0. 2 2s are 4, 1 carried. 2 5s are 10 and 0. Then again 2 1s are 2, 2 2s are 4, 1 carried. 2 5s are 10. Then 5 2s are 10, 2 carried. 25, 5 5s are 25. Then 5 5s are 25 and 5 1s are 5. So I have written the prime factors at the last. So what are how many numbers are there? 2 into 2 into 2, 5 into 5 into 5. So just pair it up. So 2 2s are first 2 have got paired up and 2 5s have got paired up. Single 5 and single 2 are left. Okay, so which means that this is not a perfect square number, since all the factors are not getting paired up. Okay, so what we'll do, we'll now just do simple calculation. Okay, the square of 3 is what? 9. 3 3s are 9. So similarly, the square of 30 would be what? 30 into 30 would be 900. Okay, so this means that 900 is just a 3-digit number. 900 is a perfect square, but it is just 3-digit number. We have to find the smallest 4-digit number which is a perfect square. So that is 900 can't be that number. Move to the next number. 30 square is 900. It is not the number. Then we will move to the next number, which is 31. We will find the square of 31. That is 961. Again, it is a 3-digit number. So this is also not our answer. Then move to the next number, which is 32. If you multiply 32 by itself, what you will get? 1024, which is a 4-digit number. 1000 was the smallest 4-digit number, but that was not a perfect square number. We have to find the smallest 4-digit number which is also a perfect square. So 1024, which is square of 32, is a perfect square number. Therefore 1024 is the smallest 4-digit number which is a perfect square. Moving on to the next question. By what least number should the following be divided to get a perfect square. Okay, so these type of question where they should be divided or multiplied are very easy. All you have to do is find prime factors. Okay, so the first part is 4056. So 2 2s are 4, 0 0, 2 2s are 4, 1 carry, this would be 16, 2 8s are 16. Then 2 1s are 2, 2 zeros are 0, 2 1s are 2, 2 4s are 8. Then 2 5s are 10, 1 is there, so 1 doesn't comes in the table of 2, so we will take it 0 times. Okay, so this will become what? 14. So 2 7s are 14. Then now in the last we have what? 7, which is not a even number, so now we can't divide this number by 2, so we will take it by 3. So 3 1s are 3, 2 is left, so this will become 20, 2 6 are 18, again 20 minus 18 will be 2 will be left, this will become 27, 2 9s are 27. Then again what we have got? 169. So 13 1s are 13, 16 minus 13 would be 3 left, and this will become 39, 13 3s are 39. Then again 13 1s are 13. So see, we'll just write the prime factors of this number. So numbers are how many? 1 2 3, 3 2s, 1 3 and 13. So 2 into 2 into 2 into 13 into 3 into 13 into 13. First of all, we'll do what? We'll just pair up the numbers which can be paired up. We'll pair it up. So 2 into 2 is paired up, 13 into 13 is paired up. What is left? 2 and 3 are left, so the number which is left, we'll just multiply it. Okay, so 2 3s are 6. Now two numbers are already paired up. All right, now if you want to make this number a perfect square, they are asking you, remember, they are asking you by what number should we divide the given number to make it a perfect square. So these are the factors. इन सबको multiply कर दोगे वापस, you would get 4556. पर हमें बताना है कि by what number should I multiply, divide. So we will divide by that number only which is not making a pair. ठीक है, 2 is making a pair, 13 is making a pair. But if I remove this 6 from this expression, so we'll have, what will be left? We'll be left with two numbers. One is 2, which is a perfect square, and one is 13, which is a perfect square. Or just move a step ahead above. Okay, there are 2 into 2 into 2, then there's 3, then there's 13 into 13. If we remove these two numbers, okay, if I remove these two numbers, what factors are left? Just look carefully. 2 2s are left and 2 13 are left. Okay, both would make a pair. So then this number would become a what? A perfect square number. So 6, if I remove this 6, so 6 is the least number. Divide means removing. ठीक है, अगर कुछ ऐड करने को कहेंगे तब मल्टीप्लिकेशन करेंगे. So if 6 is the least number with which if I divide, so if I divide it, तो 6 and 6 will be gone. ठीक है, then 456 will become a perfect square number. So therefore 6 is the least number by which 4056 will be divided to get a perfect square number. Next part of the same question is 8820. Okay, so 8820, first what we'll do, we'll just find out the prime factors. So 2 4s are 8, 2 4s are 8, 2 1s are 2, 2 zeros are 0. Then 2 2s are 4, 2 2s are 4, 2 zeros are 1 is not there in 2 table, so we will take it 0 times, so that will become 10. 2 5s are 10. Then again 3 times from the table of 3, 3 7s are 21, 1 is left, 3 3s are 9, the 1 is left, 3 5s are 15. Then 3 2s are 6, 1 is left, 3 4s are 12, 1 is left, 3 5s are 15. Then 5 4s are 20, 4 is left, 45, it will become 45, 5 9s are 45. Then 7 7s are 49, and 7 1s are 7. So these are the factors of 8820. So 2 into 2, 3 into 3, 5 into 7 into 7. Pair it up. After pairing up, what we have seen that we have a pair for 2, we have a pair for 3. We don't have any pair for 5 when we have a pair for 7. So what is that number which should be removed by division? So if this is a square, this is paired up, this is paired up, this is not paired up, this is paired up. So the number which is not paired up, we always multiply and divide with that number only. Okay, keep in mind, the number which is not paired up, all the numbers which are paired up will not touch them. The number which is not paired up, we'll always multiply or divide with that. Okay, so if I divide this expression by 5, so what will happen? 5 and 5 would be removed, cancel out जाएंगे, तो क्या बचेगा? 3 numbers would remain and all those 3 numbers are paired up. So 5 is the least number by which 8820 should be divided to get a perfect square number. Alright. Next question is similar question. The only difference is by what least number should the following be multiplied. Okay, now we have to do multiplication. So first part is 9075. We have to do the same process. First process is of prime factorization and that would remain same in this question also and last question also. So 9075 we'll just write and find prime factorization. So 3 is a 9, 3 0 0, 3 2 is 6, 1 carry, 3 5 is 15. Again now 5 6 is 30, 5 0 is 0 and that will become 25, 5 5 is 25. Again 5 1 is 5, 1 left, 5 2 is 10, 5 1 is 5, 11 1 is 11, 1 left, 11 1 is 11. So the prime factors are 3 into 5 into 5 into 11 into 11. Okay, now see, 5 is paired up, 11 is paired up. What is not paired up? 3. Okay, so here what we have to do, keep in mind we have to do multiplication. So now we can't divide, we'll multiply. So if you multiply, everything else is paired up. If I multiply this 3 with another 3, this also will get paired up. Yes, therefore what do we need to pair this 3 up? We need one more 3. So 3 is the least number that should be multiplied to make 975 a perfect square number. Okay, so another part for this same question, 4851. Again we'll do prime factors of the number 4851. First it will go with 3. So 3 1s are 3, 1 is left, 3 6 are 18, then 3 1s are 3, 2 is left, 3 7s are 81, then 3 again, 3 5s are 15, 1 is left, 3 3s are 9, 2 is left, 2 9s are 3 9s are 15, 3 3s are 9 and 3 9s are 27. Then after this I've taken it by 11. So 11 4s are 44, 9 is left, 11 9s are 99. What we have got? 49. It can again go with 7. So 7 7s are 49 and then 7 1s are 7. So what are the prime factors? Prime factors would be 3 into 3 into 7 into 7 into 11. Okay, so 3 is paired up, 7 is paired up. What is not paired up? 11. So if we multiply this 11 with one more 11, so this will also get paired up. So 11, this 11 is the least number. 11 is the least number by which 4851 should be multiplied to get a perfect square number. Okay, that would be all for today. And this completes your exercise 3.1. If there's any doubt, you can always ask.